Um, Hello everybody, Mastermind here. So today we're doing a new course or a new subject, which is mathematics, and talk about a very important and a very enticing topic, which is indices. Well, the simplest way you can define indices tells you how many times a number is repeated, or you can say it tells you how many times an alphabet is repeated. For example, if you see an alphabet A raised to the power 3, means A is repeated 3 times. As this can be expressed as A times A times A. But if you see a number like 2 raised to the power 3, it means that 2 is repeated how many times? 2 times 2 times 2. So indices, all we want to do is how we can maneuver or manipulate numbers or equations or alphabet that express that like this, and use to solve one or two calculations. So we just in this video just run through some important laws of indices, and I'll try to give basic examples of each law so you can really understand it. So let's run through some important laws of indices. So I'll try and take us through these laws and how we can apply it to questions. Basically, indices, wherever question you are given, you have to apply 1, 2, 3, even 4 laws in solving such equations. So the first one, I usually call it product law. Product law. Now it's as simple as this. It's expressed as this. If you have a base, by the way, the alphabet and the number that is below is called the base, and the power is called the exponent. That's what is the number is, the value that's on top of the base is called the exponent. Now if you have a raised to the power m, product in mathematics has to do with multiplication. That's times. That's what we call it in Nigeria here. Times a raised to the power n. Now, as long as the bases are the same thing, so there's a way we can solve this to get an answer. This is going to be equals to a raised to the power n plus n. So let's try an example. We have an example, for example, e.g., we have to solve 2 raised to the power 3 multiplied by 2 raised to the power 4. Now, if you compare this, we have a to 2, we have m to 3, we have another a to 2, and we have n to 4. So, using this format, we can say that since we took one of this a as the answer, it must be just one of these 2, and then coming to this, just add their powers as like saying we did 10 plus 10, so just going to be 3 plus 4. We have 3 plus 4, and 3 plus 4 sums up to 7, which is the answer is going to be 2 raised to the power 7, which in the express. Okay, let's talk about the expression for now. So just to show you how you can evaluate it. That's what it means that 2 appears 7 times. If you want to break it down, you're going to write between 2 7 times. So that's about the product rule. Let's do another one. Another important rule I should know is the quotient rule. The quotient rule. Well, the word quotient, you can see it as division, or some people call it fraction. It works. Now, let me give you a general form saying like this. You have a raised to the power n over, you know I said quotient means division. A raised to the power n over a raised to the power n. This can easily be expressed as a raised to the power n minus n. As long as the bases are the same thing, you can convert this quotient into subtraction. So the gist here is that quotient in laws of indices, the powers are subtracted, and then products powers are add or added together. So let's give an example to evaluate this. Now let me use another number so it's not look as if I'm using just 2. So we have an example, e.g. we have 3 raised to power 3 over 3 raised to power 2. To evaluate this, it's simply going to be the same way. You can compare it a to 3, m to 3, this a to this second 3, and this m to this second 2. If you can, the same way you pick one of this a, you pick one of this 3, it's going to be 3. Then the same way we did m minus n, that's the power in the up or numerator, and the power in the denominator is going to be 3 minus 2, and 3 minus 2 is 1. So the answer is going to be 3 plus 1, which is just with 3 as the answer to this basic question. So we move on to 2 more laws, and then I'll give you, an expression. I'll see if you can solve it. The laws of indices. Let's run through 2 important ones. We also have, I like calling it the reciprocal rule. The reciprocal rule. Now, when you hear the word reciprocal in maths, it can be simply expressed or stated as 1 over a number. Like 1 over 10, 1 over 20, 1 over any number, 1 over x or variable. The word reciprocal means 1 over. So the general expression for this is you have 1 over a raised to power n. 1 over, the 1 over here shows the reciprocal. This can be expressed as a raised to power minus n. Now, let me give an example that can show you how you can solve this. For example, we have 1 over, let me use another number, let's say 4 raised to power 2. For example, this can be compared with this. We have 1 to 1, we have a to 4, and we have m to 2. So the same way here, the a just came up, and here just had minus. Same way, this 4 will just come up. It just be equals to 4, and then put a minus, and then invert to 2. So if you have this, now let's give you one. You feel free to pause the video and try it. Let's say you have on number, you have 1 over 5 is equal to 7. What do you think this will be using the reciprocal rule? Like I said, feel free to pause the video and try it out. So following the rule, it's just going to be 5, write it out, then write your negative sign, then put your power of 7. So that's simple as that. So another important law that you also need to note is what I like calling the radical law. Now let me write it here. You have the radical law. Or what is radical rule? And what works. Now the word radical in maths can be simply expressed as something that has a square root or a square root. So none of that is a square root, that's a root. Can be square root, can be cube root, can be any root. It doesn't have to be a root. So a general rule I can give it is if you have the nth root of a base raised to power a power, this basically means nth root. Now this nth here can be 2. If it is 2, it's called square root. It can be 3, it's called cube root. Then 4 is 4th root, 5th is 5 is 5th root, and so on. That's n here can be any number that's starting from 2 upward. So this can be easily expressed as just work with me, something simple. Write the base first as usual, and then you write the power n that the base was initially carrying, and put over n. So basically, the base raised power is initial power over n. So if you have a question like this, and you have, for example, you have expressed, if you have to Let's simplify cube root of, let's see, 6 raised to the power 5. Now we can compare this. Here, n is 3, a is 6, then n is 5, and then the roots is cube root. So same way we put or we wrote the base first. So the base here is 6. So it's going to be 6 first, and then same way we first put the power of the initial power of the base, which was n here. So it goes to the initial power of 6, which was 5. Put it at 5, then over the power of the roots, which is 3. So this is basically 6 raised to the power 5 over 3. Now, same way, let's give you one to try. Like I said, feel free to pause the video and try it. If you have an equation or a question like this, simplify 4th root of 7 raised to the power, using this raised to the power 8. Then feel free to convert it into its index form. Let's call an index form. Because when you hear the word index, like the index means something raised to the power. If you have this, following the root that was initially stated, write this first, which is 7. It's going to be 7, which is the base. And then the initial power of 7, which was the initial power of a, which was n. The initial power of 7, which is 8. Then over the power of the roots, which is 4. So this is the index form of this. Quite simple, right? So let's run through one more laws, and then I'll give you something to practice as in anticipation of our next video. We have, let me call it exponent product rule. Exponent product rule. Exponent product rule. Now, the expression is simply we have a plus power n all multiplied by n. This is an exponent of a and another exponent of the whole function, which is a raised to power n. The simple way to solve to express this is just going to be the base, which is a raised to power n times n. So how do we try this? Let's try an example. If you have, for example, if you have 4 raised to power 3 all raised to power 5. Following this, you can compare it. A here is 4, m here is 3, and n here is what? 5. So the first thing we do, we write the base, which is 4 here. It's just going to be 4. Then the product of the power of the exponent. So the product of 3 and 5. 4 times 4 raised to power 3 times 5. And 3 times 5 is equal to 15. So the answer will be 4 raised to power 15 is index form. So as usual, let me give us a track. That's what we have. You have to analyze, to evaluate, let's see, 7 raised to power 4 all raised to power 6. So feel free to pause the video and take a minute to try it to see if you can get the correct answer. So together, following the same rule, write out the base list. We have 7, then the product of the exponents, which is 4 times 6, and 4 times 6 should sum to amount to 24. It's going to be 7 raised to power 24 as the answer. So you have a question to ask based on the laws I've given. I'm going to give you a question right now, and feel free to try it in anticipation of our next video. You can try it. So I have these 2 lovely questions on the board, which feel free to try just in anticipation of our next video on how you can. So please evaluate 4 raised to power 5 over 2 raised to power 6 as question A, and evaluate 16 raised to power 1 over 2 times is equal to 2 over 3. So using the laws I've given you, see if you can drop your, feel free to drop your answers in the comment section, and you know, and on our next video we'll see if you are correct or not. Right, thank you for your time, thank you for your patience, thank you for watching this video. I remain Mastermind of Mastermind Tutorial.